7.1 Cartesian vector. Okay, for the vector, we have unit vectors. So a unit vector across y-axis, we call it j hat. And the unit vector across the x-axis, we call it I hat. What is the unit vector? The magnitude of that is 1. If I want to show it, the I is equivalent to u. X component is 1, and there is no y component, right? There's 1 and 0 for I. For j, let me just do this right here. J is equal to just as a unit vector means go 1 unit up. 1 unit up means you don't have any x component, and it is 1 unit up. 0, 1 means you don't move in the x direction, you just move in the y direction, 1 unit. So any vector, we can define it as this unit vector. So we'll do an example later. So what is the magnitude of the vector? If the u above that is a hat, it means as a vector is equal to u1 and u2. u1 is your x component, how much it goes to the right and left. And u2 is your y component, how much you go up, down. Of course, the magnitude of that is the x component power 2 plus the y component power 2 square root. So using the Pythagorean theorem, we do that. Also, when you want to add two vector or subtract two vector, if you have vectors in their x components, you write it in the y components of two vector. The addition of the two vector, you add the x components of the two vector, u1 and v1 here. And then you add the y component. So this will give you addition of these two vector. And when you subtract, of course, you subtract the x component. u1 minus v1 here. Subtract the y component, u2 minus v2 here. Give you the subtract of these two vectors. If you multiply a vector by constant, you just simply multiply x and y value of that by a constant. So if you have a point at P1 and P2, here is your initial point is P1, and here is P2. And you want to define vector P1, P2. This is a vector P1, P2. What you do, let's say you have an x1, y1 here, x1, y1 for x and y common of P1, and you have x2, y2 as component of that. So vector P1, P2 is x2 minus x1, the final point, minus the initial point, x1. And the y component is going to be y2 minus y1. And the second one minus the first one. And the magnitude of that is, of course, the x component, the total x component, that's 1 power 2. Oh, plus the y component power 2 square root of that give you the magnitude of the P1, P2. Geometric vectors. Knowing that this is my vector V, it making linear angle theta. Of course, the y component is opposite. Opposite is what? Is a sine, is a y component, so it's going to be V sine theta. And adjacent is cosine. This side going to be V cosine theta. So my x component is V cosine theta, my y component is going to be V sine theta, as we did before in previous unit. Now, expressing the vector in terms of the unit vector I and j, we talk about the unit I is, so 2 means 2 in x direction, 2i. And 1 means you move one unit in j direction, plus j, 1j. 0 means you don't have any I, negative 8j means you just have a y component, negative 8b. 5 and 0 means you just have an I component in x direction. 5i and there is no j. Express each vector in the form AB. Of course, this is 1, 1, I and j. Equation of the I is x. Of the j is y, so it's going to be 1, 1. Negative 2.5i plus 3.3j means your x component is negative 2.5, y component is 3.3. Negative 4i don't have j means the y component is 0 and just have x component which is negative 4. Given the points P, Q, and R, find QP. QP is P minus Q. It's just a typo here. It's P minus Q. It's always second one minus first one. Here is P. P here is negative 2. So what I have, negative 2 minus 1. And y2 minus y1, 3 minus 3 minus 3. So what you have is negative 1 and 6. So it's a typo here. So find RP. RP is P minus R, as you see, the magnitude, P minus R. X component in power 2 plus y component in power 2 square root give you the magnitude. If the x is negative 2 minus r is minus 6, and y2 minus 1 is 3 minus 5 power 2. So simplify, get a square root of 20. Write the force as a Cartesian vector, 300 applied at 50 to the horizontal. So here's a 350 to horizontal. You need to find the x and y component. X component is going to be 300 cosine theta because this is going to be your adjacent is cosine. And y component is 300 sine theta. Sine is opposite, as we did before. In the term of the I and j, put in a calculator, the x component is 192.8. And y component is 229.8. In terms of I and j, this is going to be this I plus that j. 200 applied to the west, so just the vector to the west. Of course, you just have x component. There's no y component. Just can put it as a negative 200i. 150 applied 32 to the vertical. 32 to the vertical is like that. Not opposite gonna be your x value. Opposite is sine. See, your x value gonna be sine. And adjacent is your y value. Adjacent is cosine. Now cosine is there. It's 250 sine 32, 250 cosine 32. And you just put in a calculator, you get this two number. And you know, this is your I component, and here is your j component. Okay, ship's course is set as a bearing of the 192 with a speed of 30 knots, and the current is flowing from bearing of 112 at a 14 knot. Use a Cartesian vector to determine the resultant velocity of the ship. So you need to find the x and y component of each vector. As you see, we do the x and y component of each vector. When you want to add these two vectors, simply add the x component to the x component and y component to the y component. This is the resultant. And using, I want to find the magnitude, I put Pythagorean theorem, the x component power 2 plus the y component power 2. You have that. Find the angle is the y value divided by x value, tan inverse of that. Give you the angle. Since this is negative, the x and y is negative, so you're in this quadrant, it's going to be your angle. The resultant going to be 30.8 west, that angle, which is 51.43 south, or south 38.51 west. You do 90 degree minus 51, you will get that 38. Okay, so to look at this question, so question number 1, you just do A, B, C. Question 2, A, B, C. Question 3, you can do number H, C. Question number 4, just do for H and C. Question number 5, you do. Question number 7, A, B, C. Question number 8, A and B.